Okay. Hello. So last time we got through what's like the main part of this presentation, which was talking about creating new geoms and stats of ggplot2. Does anyone, I think everyone was here last time. Does anyone have any questions? Does anyone, maybe everyone was here. Does anyone have any questions about what that looked like or how that works exactly? Today, we're going to talk just about various important details. It's going to be a little bit less of like a story. We're not going to have like two geoms and stats that we hang on to throughout. We're just going to hit a couple of topics. So there are no questions, just, throw them out throughout if they come up.
Let me say this at the beginning, just so they're forewarned. You, for those of you in the class, maybe for the rest of you too, you will have an assignment on this, okay? So it's going to be helpful to really like watch what he's saying and actually ask questions and engage with him if you do have those questions.
Yeah. And also just so you know, these slides are available on the internet. And so I'll get that URL out to you guys. Starting off, the first thing we're going to talk about is prototypes. So I don't know if you remember on Monday, the language to describe the geoms and stats is a little awkward. I was calling them objects. If you're familiar with object-oriented systems, you might look at them and think that they're classes. They're not classes. This is related to a comment Dr. Kill made about how ggplot2 came from proto, which itself is like this complicated object-oriented thing that uses prototypes. Most of the time when you're developing ggplot2, certainly when you're using it, you don't care what these geom and stat objects are, capital G, capital S. But when you're developing it, you might run into weird problems. On homework, you might run into weird problems. And this is a sort of so here, this is just a basic introduction to like ggplot2. Remember, this is the function that we use to create ggplot2 objects. Typically, the first argument is the name of the object. So you see we're making A, it has name A. The second argument is what we're inheriting from. Before, the second argument was like a capital G geom or capital S stat. It could have just been geom or stat, or maybe we're inheriting from geom points to make use of its draw capabilities. Here we're inheriting from nothing, like this sort of null. And that means we're sort of starting from scratch. So here we're creating A, and it's going to have this sort of element, this field X, which is initialized at 1, and it has a function or a method, which you can maybe see when you call it, it's just going to increment X by 1. And so after we make A, if we look at A and dereference X, we see it has a value of 1. If we call the increment, it goes up to 2, and then if we call it twice, it goes up to 4. So this hopefully makes sense to everyone. Now this is, so like I said, these things are not classes, they're prototypes. I just talked through that, so we're fine. So here now, we have the same example where we have A with X and increment. We can inherit, right? So we can make a new object or a new prototype B, call it B, and it's just a copy of A. Right? And so if we look at Bx, it's 1. If we increment A, Bx is now 2. Like, that's weird. That's not what you would expect. You guys in the comp class have been learning about copy on, modify, that kind of behavior. And so something like that is happening, right? If we increment B, it goes up to 3. So B was 1, we incremented the A, B went up to 2, now B's at 3. If we increment A now, B is still at 3. So up here, when we incremented A, Bx went up, and then we incremented B, and then we incremented A, and Bx did not go up. And so this is messed up. This is annoying and weird, and this is because these are prototypes. And we're going to see what's really happening is when you inherit. So here, B is inheriting from A. This X is still pointing at A's X. And then when you modify the X, that is B's, it's no longer pointing back to A. So again, you don't have to totally understand what's happening here, but just know that when you're developing ggplot code, if you run into weird stuff, look at what prototype systems look like, because that could be your problem.
If I can maybe say something else about that. So I think if you're coming from an object-oriented background, this kind of thing is probably going to feel pretty familiar to you, in the sense that the object A has a data member called X. Okay. Now you could modify that yourself, which is weird, kind of coming from another language. But usually in these kinds of contexts, you'll have an object-oriented system where you have an object in a class, and that object has data members associated with it. So think it's a named list, and that named list has elements, and those elements have like numbers associated. Okay. Now, in many object-oriented systems, you probably can't actually modify the elements of that list. They're stuck. Okay. They're private. Okay. The only thing that can modify them is, this is weird, but it's like what you see in lines 5 through 7 here, is a method that is a member of the class. So and it belongs to the object. Okay. And when you call that method, it modifies the private data member of that class. Okay. So, and then that would be like the only way to possibly do it. Okay. The weird thing here, and I'm guessing this is what gets with the prototypes, but I haven't actually kind of dug into that. Like, why is it called a prototype versus kind of a class? I think probably a better way to think about it is it's an object-oriented system that has these features, right? And the feature that it has that's a distinguishing one is this kind of weirdness that he showed in lines kind of 19 through 25. But maybe that's not so weird if you think about this kind of like as a, and I think actually you're getting to this. But if you think to environments, and if you think of environments as a type of object-oriented system, maybe that's not so strange. And so, but that naming data member, okay, in the sense of element of a list, okay, this is probably how a computer scientist would think about this. That a data member is just an element of a list, like a named list, and that in this case, inc would be a method that modifies what would presumably be a private, like a private variable to that object. But there's no distinction here between private and public. So this is just how it is.
Yeah, and I think what's particularly strange perhaps is that it's very unclear where B, like where X, like B $X lives.
Yeah.
Like where is that data object? Is it in A or is it in B? And that's where the prototype, I believe the prototype system really differs from classes because of it's so lazy.
Yeah, I suspect the answer is both.
It's both.
And that it's the lexical scoping rules that R uses that's going to determine what the value is that comes back.
I think it's more copy on modify.
You're about to tell.
Yeah, well, no, actually, we're just gonna leave this. So yeah, this is weird.
That's a question of homework.
No, I know what's going on. Mostly. Do you know what's going on? Mostly.
Yeah. Something like that. Okay. And
Is there any sort of like lazy equals false set and not like?
No. But you could probably sort of force them all to copy by like a hacky thing, but I don't think there's an official way to do that. Like a, what was it called? That anyways, like a hard, like a deep copy versus a soft copy, because they start out as soft or shallow.
my guess is that it's maybe less about laziness, which you should probably associate with like a function concept, and more about environments and scoping. That like and this is totally conjecture because I have not dug into this, but my guess is that on line 15, so he increments A, right? So let's just suppose that A is an environment that has something called X in it because that's how it was defined on line 3, right? When he increments B and he asks B, where is X, right? That B is known in that environment and can see X not in its own environment, but in its parent environment, because that's how R's environment system works, right? If you look for a binding, the bind doesn't exist, it's going to go up to the next one. Kind of that's the default-ish behavior. Okay. Now, by contrast, in line 19, he increments B's own X. And so I'm guessing what happens there is that it actually increments and it binds X in B's environment. So now there's two copies of X that run around. There's the one in B's environment, and there's a copy of X, or there's a binding to X in B's parent environment, which is A, which has a different value. And so it's kind of like using the environments in an interesting way to do something object-oriented.
Yes.
If you had incremented A twice in line 23, what would be have B's X?
It'd still be free.
It'd still be.
At this point, anything you do to the X in A is not gonna affect B's because B has its own X. Because it's, as you modified it, it made its own binding. Like-
Yeah, so it's name mask in that environment.
Yes,
It's
well,
name mask. So when
yeah,
you ask
that's
B for X, it gives you its X
Yeah.
and not its parents,
And we're-
not daddy's.
and we're
X.
about to see a little bit into,
That's the way you should think about that.
we're gonna see a little bit about how that lookup works actually right now. So leaving behind this weird example of proto objects that are not used for ggplot2, we can look at geom complete, which if you remember, this is what we wrote last time. This draws complete graphs, given a set of XY coordinates. And so we can see, you know, I know people are very familiar with is.environment because you all had that quiz that you read everything for.
They did, I know
Yeah.
they did.
Even though they had the theory exam.
That's right, that's why they did it.
Yep.
They know they're not more important than Harvard.
Yeah.
So-
But yeah, so we can tell that geom complete is an environment. It's not a list, even though we're dereferencing with the $, it's an environment, because that's what this predicate tells us. And so we know that we can use the ls function on it to see the bindings that exist in that environment. Now, if you can think back, when you just print out geom complete, we see everything that's defined, and it's way more than these 6 things. Like, just to start, we know that there's a draw group, but there's also a draw panel and a draw layer, but those are not here. In fact, these are just what we're masking. And so when we create using ggproto and we sort of say, hey, instead of the default draw group, use this one, that's what we see here. So these are the things that we specify that are different from what geom complete is inheriting from. And then there's this last thing, super, which is how the inheritance system works. So that's how we know where to look up. So super is actually going to point at geom. And then from geom super is going to point at, I think there's one more thing about geom, and then it's going to point at like something in it, which is very reminiscent to like the namespace stuff, generally environments. And so you can see when we do ls, there's no draw layer, but we can dereference and get a draw layer. And that's because this $sign knows to go look at the super, which is just the geom. And so this is just the standard draw layer that comes with the geom. Does that make sense? Okay. Yeah, so that's ggproto. And now we're going to take the left. We're going to talk about something else. So I don't know if you all remember, but last time we looked a little bit at this draw panel function. Generally the draw functions, and we talked a lot about, if you go back, what's going on here, where we have it's called to the grid function that creates blocks. And there's another line of particular interest, which is this line 13, where we are transforming somehow our data from data into an object called ports. And this line is really important. And it's not really clear what's going on. I had mentioned that loosely this can be understood as transforming our data to be, it comes in sort of data units. So whatever units, the literal data frame that you're typing in is defined in. But that's not very useful to the grobs function, or to the grob functions. And it needs to be defined in terms of like the plotting coordinates. And that's what this is doing. And so we're going to sort of do our own version of ports transform first. And then we'll see how that matches up with the internals. So to do that, can you all read that code? I know it's very small. Okay. We are going to start off with this very simple data set. So here we have X and Y, which each gets range 1 to 10, and we can plot it using geometry. That makes sense. Now the first, so if we're interested in transforming from the sort of data units into some kind of plotting units, the first thing we need to know is what is the domain of that transformation. So we're going to be mapping one set of numbers to another set. What is the first set? Well, somewhere to start might be looking at the range of the data itself. Okay, so obviously X and Y both go from 1 to 10. And if we plot a bounding box around that range, we see that that's almost right, but that's not it. Like the domain, so our data coordinates extend obviously past this box. And how far do they extend is the question. Well, I'm sure you all have seen like this argument in the scale X or scale Y continuous, which is like a scale expansion, where it applies either, some combination of multiplicative and additive expansion to the range of your data. And the default is to do a multiplicative expansion of like 5%. And if we call this function from the scales package, which is what ggplot2 uses, we see that the expanded range of the data goes from 0.55 to 10.45. If we draw a box now, we see it's perfect, right? So this is the range of the data as far as ggplot2 is concerned. And so ggplot2 is somehow taking the data from this range and transforming it into plotting coordinates. Okay, so we're going to remember this value, 0.55, 10.45. And now we're going to try and plot grobs directly on top of these points, right? Just from outside of ggplot, how do we do that? Well, if we just naively, you try to use a quick note. So right now we're using grid dot points. Earlier we saw the function called points grob, and then we had to draw the graphical objects using grid dot draw. Is that familiar? That's fine. It's a little bit of a pain. There's like a nice convenience function from grid that both creates the grobs and draws them at the same time. That's what this is. So this function is exactly the same as grob points. It's just going the additional step and going ahead and drawing for us. If we use grid dot points and we supply values 1 and 1 to x and y, the point is here. Awesome, right? You might think that the point would be somewhere down here because x and y, both equal 1 somewhere in this area, but that is not the case. And if we do 10 and 10, it's just barely moved. 100, 100, it's still up there. So how are we going to get this point, this grid function to draw the points in the right spot? Well, the first step is we need to use the right units. The units that ggplot2 uses, that really, I think everyone uses, unless you're doing like annotations maybe, are this NPC. And I meant to look this up before. I usually call it the wrong thing. Do you remember what NPC stands for?
We debated about this last time.
Yeah, I got it wrong.
Yeah,
I got it
look at that.
actually like damagingly wrong. I said it non-player. Yeah. We can go with that.
Yeah, we'll go with that. Not player
So
character.
non-player character coordinates. I don't want to say it wrong. Anyway, so what's happening here? Can you guys tell? So if we put 1/2 and 1/2, the point showed up in the exact middle of the plot. So you get a sense that maybe this NPC, 0, 1, 0, 1, and that's actually the case. So we can sort of put in the corners and we'll find red, and you can see that these NPC units, these are like the sort of maximal. The 0, 0 goes here, 0, 1 goes here, 1, 0 here, 1, 1 here. So this unit system is treating the plotting window as like the unit square. Does that make sense? So we have much more useful coordinates to attempt the plot with. Now, there's a problem, which is what we really want to do is put points on the corners of the data region, not the corners of the plotting region. And ggplot2 has a fancy way of doing this. We're not going to worry too much about how ggplot2 does it. What we're going to do is we're going to mimic what ggplot2 does by setting the theme to eliminate margins. And so now when we do the same sort of 1/2 and 1/2, it's actually in the middle of the plotting window. And the corners are actually the corners of the plotting window. So, okay. Now we know how to put points wherever we want on this sort of unit square by using these coordinates. And we have our original data in terms of the sort of x and y values, and we know the range that so we know that in terms of the data, this is 0.55 and that's 10.45. And so we can actually just linearly transform from the data coordinates into the plotting coordinates, and that's what we're going to do. So using some dplyr here, but there's actually a function from the scales package called rescale that linearly sort of squishes or transforms from, in this case, this range, this domain into this range. And we'll do that to both of them and see we're doing this to our original data. And when we do that, if we call group points, now it's perfect, right? And it's perfect because this is what ggplot2 is doing. ggplot2 does this exact same thing, where it does the expansion of your scale of your coordinates, and then it uses actually this function or something very much like it to figure out the right coordinates. And so let's look at that. So going back to the internals from ggplot2, we can look at this chord transform. So this is where stuff gets like slightly complicated. ggplot2 can be tricky to debug because see here we're dereferencing chord, and chord is an argument of the draw panel function. But when you're just in your global environment, that chord is not defined. And so you kind of have to know what's being used. In this case, chord is just chord Cartesian, which itself has a ggproto object associated with it. So you might know the chord underscore Cartesian function in ggplot2. It itself corresponds to a ggproto object, which has a transform method. The transform method has this, is a function of data and panel params, and it's calling transform position. And transform position has its own implementation in ggplot2. Wait, let me see what's going on here, which I couldn't find. But there is this really nice package, which I barely mentioned last time, called ggtrace, which, have you guys used the browser function before? Okay, so I'm not going to go too much into this, but in our base R, there's this function called browser. And if it's called in the execution environment of a function, it sort of transports your console to be in the execution environment. So if you have a function like sum and then it's just x plus y, and you have up here browser, then if you were to, if this is your console over here, if you were to call sum 5, 7, you would sort of be transported, and your console would be as effectively, it would exist here. And it would see the bindings x and y as 5 and 7. So here you run sum and your console gets captured. And then if you were to like type x and print it out, that would tell you that x has a value of 5. Even though in your global environment, the binding x probably doesn't exist, but it does exist in the execution environment of sum. Does that vaguely make sense? This is going to be very useful on your homework. You're going to want, I mentioned this, but you're going to want to use the browser function probably for this purpose, to figure out what's going on in the execution environment of ggplot2 methods, because they can be complicated.
In the book, you'll see this in the chapter on conditions and condition handling. So it's about like errors, how you throw errors, how you message the user.
Yeah.
And then for browser, it's going to kind of pause that evaluation, give you a REPL inside the execution part.
Yeah. And I think the homework actually links you to that chapter. So if you want a quick refresher, it's right there.
Would you put browser before or after the or if you want to see what results some of the internal parts of a function are, would you put browser before those lines are run?
Yeah, typically before, because actually in the browser, if you're sitting on our console and you press return, it does nothing. In the browser, if your sort of line is empty, you press return, it steps through the execution line by line. And so again, you can see how that would be very useful. And so browser works just fine with ggplot and ggproto. It works as you would expect, but it can actually sometimes be even difficult to like put the browser function where you want it. And so there's this really cool package called ggtrace. It's only on GitHub, but it has like functions that take, I guess you call it, it has functionals, and that essentially say, hey, stop when chord Cartesian transform is called. Like the first time it's called, put me there. Like, I don't want to put a browser call in there, but you do it, R, and it does. And when I did that, I was able to see that this sort of transform position, notice it takes this argument, panel params x rescale. And that object is defined as this, which this should look similar or familiar. Remember earlier, we rescaled our x and y values with a rescale function that was within the scales package. And that function had argument verse x and then sort of the range of that transformation and then the domain. And that's what this is. Now, this is a little bit more robust because sometimes like the coordinate transformations are like logarithmic or something like that. And so this could, instead of being a linear transformation, it'd be logarithmic, whatever, square root. But in this case, this is actually exactly the function that we just saw for the transformation. And so internally in ggplot2, it's going through the same process. And I hope I don't. If we went all the way back, which I think I can just do quickly, because I labeled these. Yeah, perfect. So here, remember, the whole point was we're trying to figure out what chord $ transform does. And it's just transforming your data to be into the coordinate system. Coordinate system in terms of those NPC units. Does that make sense? And by default, that's the Cartesian like transformation, which is just that simple linear affine like transformation. Cool. So let me skip ahead now. If that makes sense, we're going to look at something else. This is the setup data method. I think I mentioned this very briefly last time. The geom objects in ggproto support the setup data method, which allows geoms to intercept the data at the layer level before it goes to the draw functions. And so this is useful for like really quick changes. And I think, yeah, I say this is mainly for row-wise operations. So we're going to see what that means in a second. Have you guys met the dplyr function row-wise yet?
No.
No, okay. Well, when you see it, you'll remember.
Yeah, the first year sometime.
Yeah. Anyways, so we can try, and we're going to implement geom complete using a setup data method instead of the draw root method. But it's actually going to fail, and that's because it's not row-wise operations. We'll see. So, like I said, so setup data is a function that's going to take in the data and like params, don't worry about that. And it's going to return the data that after it's been quote set up and ready to go to the draw functions. And so before, the way that we manipulated the data in geom complete is we did that kind of Cartesian product. Remember, where we matched up all of the X values, we have duplicated all the XY pairs and then matched them with all the other XY pairs. And then we drew the segments, they all connected to each other. And so that's what we're doing here. We're setting up the data by doing that Cartesian product. And you can see I'm inheriting from geom segment here. And so then this data expanded goes to geom segment, just like geom segment was called. And the only other change we're making is geom segment wants X, Y, X in and Y in. But we're saying, no, we actually just want X and Y. And we're going to calculate X in and Y in during the setup phase. And at first it looks like it works. So this is using now the same geom complete that we just saw, where we have our DF circle from before, and we have the complete graph. But let's say that we want to do some kind of grouping. So here we have, now we have DF circles, plural, where we have X and Y are sort of, you can just imagine them as like slightly offset circles with like 5 points per circle. And we're going to see what it looks like. And the circles are identified with A, B, or C. And so the typical way that if you wanted to plot these 3 circles on the same plot with different colors, you would call geom complete and specify color equals class, and then it should work, but it doesn't. So this is a mess, and that's because you can see each of, like, we have these 3 circles. Here's the reds. The red points are here, 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 and here. And the green ones, you know, are similar. But like there are red lines connecting the red dots with the green dots, and the red dots with the blue dots. And that's because, remember I said the setup data intercepts the data and does a setup on, like, in terms of the layer data. So it doesn't care about what group the data belongs to or what panel you're passing. It does the transformation on the whole data frame, regardless of like the structure that's intended. And the result, like I say, is the setup data is not split, apply, combine. Remember, we went through that whole example where we split the data frame into pieces, did all of the transformations, and put it back together. The setup data doesn't care. And so when I say the setup data is best for row-wise operations, what I mean is like you have a data frame coming in with some number of rows. And then you do a transformation on the data frame that doesn't make new rows, or it could make new rows, but that transformation needs to only apply to one row at a time. Our transformation takes the data frame and then sort of matches the rows up together. And so it doesn't work. Now, if you were, for example, if you wanted a geom segment that took in XY data and then drew segments where that started at each XY pair and went out like, 1, then you could achieve that here because you would just be adding an X and Y in to the data coming in, where you sort of offset it and everything works as intended. But because this is much more complicated, the setup data doesn't work. But it's useful because notice if this implementation works, this is way easier because we're not using grid. We're not having to reach to segments, and we can just rely on the really good implementation that the ggplot2 devs created. So luckily, even though this sort of easier implementation doesn't work for more complicated use cases, there is another way to avoid grid. And that is when you create a geom object, you can actually, in the logic that the geom uses to draw plots, you can reference already created draw methods from other geoms. Now, that might not make sense, but I'm going to show you what that looks like. Yeah, so like I said, so we can actually implement geom complete correctly like this. And here's what that looks like. We can no longer inherit it from geom segment, but that's okay. So we got to set up our required aesthetics, the default aesthetics like we saw before. All that's really different is this draw group function or method. It starts off the same as what we've seen, that same Cartesian product. And before, where we took this data expand and gave it to segment scrobs, we actually just give it to geom segment drop hand. That I don't know if this set off alarm bells for you guys, because this is at the panel level, not the group level. That doesn't matter because this is implemented as geom completes draw group. And so what happens here is we say, hey, geom segment, here's a bunch of X in, Y ins. Go draw the right line segments. And here's the same example that we just saw that broke before, but it works. So the geom segment draw panel is for each group drawing the correct segments. And so this doesn't always work. If you're working on a problem where the plot that's being created is not some kind of simple combination of existing ggplot2 functionality, you'll have to reach the grid. But there are, between this and set of data, you've got quite a few options on how to avoid it. Yeah. So does that make sense? This is definitely a useful skill if you don't want to mess with grid. So I think that's pretty much all of the technical stuff that we're going to hit besides package development. So does anyone have any kind of lasting questions on ggproto, ggplot2 internals, that kind of stuff before we move on? Okay, awesome. So this talk was titled creating new geoms and stacks using ggproto. Obviously, ggplot2, its main purpose is geoms and stacks, but it does other things. And it's possible to extend ggplot2 in ways other than the implementation of new geoms and stacks. So this is going to start easy and get harder. One of the easiest things that you can do is you can kind of come up with your own color palettes. We'll see an example of this. You can also, pretty easy again, come up with your own themes. You might even now, for homework assignments, be using an existing theme like theme minimal, but making a few changes. That's fine. Or you could actually just create your own theme and always use that for standardized graphics. You can also create new coordinate systems, so it can be a little bit more complicated. You can create new scales, and you can create new faceting systems. I'm going to show brief examples of each of these. So starting up here with new color palettes. So here's some data to work with. It's the penguins data again. And this is the default sort of scale color discrete. We can, here's a package GG Psi, and it exports scale color Star Trek. Ooh. So I guess I'm not a Star Trek person, but maybe these are more Trekky than these. They look very similar to my eye, but you can see that, you know, they're different. And the Star Trek example is kind of silly, but maybe post-graduation when you have a job, if you want graphics to all look the same, maybe your company has colors that they care about. It's very easy to create a new scale. Sorry, a new color palette scale, not so even make a new scale. I'm not going to show any of the code to do this stuff because outside the scope, but you notice like I'm dereferencing these, and that's so if you want to know, hey, how did they make this? Go to GitHub, look at GG Psi, look at the definition of this and kind of follow it, and you'll see how they do it. Next up is the themes, like I said. So again, this is pretty simple, and you know, any of you could write a theme in like an hour probably, but here it is. Again, this is like nice for creating standardized graphics if you work somewhere. Also, sometimes journals will give you themes to use if you're working in a journal. There are themes that look like Excel if you want to like camouflage. There are also themes that look like base graphics if you need the camouflage as a ggplot2 user. Yeah, so themes, color palettes, easy extensions. Now getting at something a little more complicated. Remember earlier we were using coord Cartesian and that had its own ggproto implementation. You can create new coordinate systems. Here's one, which doesn't look like a coordinate system, but it is. I don't know what coord flex cart means. I have no idea. It's from this lemon package, and what it allows for is, notice these axis labels look a little different. You know, we've got these brackets, and the idea is for strict charts, or in this case, the sort of B-swarm plot, it might be more useful to indicate that these jittered plots are dense. Now, I'm not necessarily endorsing these extensions. Like this, I think has a problem maybe, which indicates that maybe this is itself some kind of range of interests. I don't know. But here's an example of how you might, what an extended coordinate system might look like. So moving on, this is a more complicated extension. Not only is this implementing kind of a new scale, it's actually breaking ggplot2 in this sense. So this graphic might not look too strange at first, but if you look, we have these circles drawn, or these ellipses. These ellipses, which each have a color, and the color of the ellipse corresponds to the species of penguin that are like, that's kind of in that area. So this is the Adelaide chinstrap and penguins. In the same graphic, there's another color scale, which is we're sort of coloring the points by their body mass. If you try to do this without line 3 up here, it won't work. ggplot will say like multiple scales present for color, and it'll break. This package GGU scale sort of, it's kind of implementing another scale, it's kind of circumventing ggplot2, but it's allowing us to have multiple color scales on the same graphic. So I guess it's pretty interesting. There are other ways to implement new scales. I think it's really hard. The code that the packages that I found were actually not working very well, so I didn't include them. But if you're interested, go check it out. There was one in particular that allowed for like your scale to be a 3-dimensional color space that was like a cube with this. But yeah, so interesting. Lastly is new faceting systems. So this is, to my understanding, this is the hardest way to extend ggplot2. I've never messed with it. But this is facet zoom from ggforce, which this might not look like a facet at first, but technically it is. And what's happened is we've said, hey, zoom in on this species of penguin. So up here is the plot that's created by G on point, and down here is a facet, which is just looking at this region. So, you know, obviously making new faceting systems is very powerful. It's also not very easy. You have to be really familiar, not only with the ggproto stuff and grid stuff that I talked about, but there's actually a whole nother level of ggplot2 sort of implementation called gtable, which is how actually remember those draw methods at the end sort of return a grob? Well, those grobs are all collected into a gtable, And then ggplot2 goes and draws the G tables, that singular G table. That's my general understanding. But the faceting system, you have to kind of dig into that. Another fun example of a new facet is from geofacet. And this is kind of similar to facet wrap or facet grid, except this is a map, right? This is the United States. So each of these little boxes is a state in the general area. So again, this is just another example of an extension. Which, you know, if you guys want to, you have an idea for a fun facet system, go for it. Tell me how it goes. Yeah, so I think that's it. Yeah, so that's it on the other ways to extend. The last thing that we're going to talk about, and this probably take a bit, is what package development looks like when you're extending ggplot2. And we're going to kind of roll it back. We're not going to talk about generally extending. This is specifically for geoms and stats, although these ideas, I'm sure, do extend to the other methods. So when you're extending ggplot2, your package is going to look a little bit different than a typical R package. Does anyone in here have experience with making typical R packages? Well, kind of. I know you kind of. I know you definitely. So that's okay. We're not assuming any knowledge. This is just going to be briefly about it. Although, if anyone is interested, there's this package by Hadley Wickham. Sorry, not package, book. Called R packages, which does a really good job of taking you through the process of developing an R package, and getting started is actually really easy. And I recommend that you look at it if you're interested. But like I said, ggplot2 extensions go a little bit past what he talks about, because, and you were talking about this last time, ggplot2 extensions export functions. Remember, we had like geom_complete. But they also export ggproto objects, which we now know are environments. So, you know, it's like you said, it's kind of like we're exporting data. Luckily, from our perspective, it doesn't make much of a difference. It's just you have to kind of know how to do it. So we're going to quickly look at some source code from ggdensity. Just for a second to see what that might look like. I know that none of you have experience with package development really, and that's okay. So this is GitHub. This is the public repository of ggdensity. I'm scrolling through here, A, to show you guys how this works, but B, to show you guys how to look at source code on GitHub, because like on the homework, you're gonna probably get stuck, and the way to get unstuck is going to be looking at repos either on GitHub on your browser, or like we talked about, cloning them down and looking at them locally. So let me go back in that case. Yeah. So this is the landing page of Nope, that's me. This is the landing page of ggdensity. This is really zoomed in. That's fine. And so what this is like a directory, right? So it's just like you're in Windows Explorer or whatever it's called on Mac, where you're just clicking through. There's a README down here. That's, you know, it's a README. We don't have to worry about it too much. The way that R packages are organized is the code that's being exported that defines functions or environments that users are going to use are located in the R directory. Right here, click it, and then there are a bunch of .R script files. Everyone organizes things a little bit differently. I organize ggdensity slightly different from how ggplot2 organizes, from how the tidyverse organizes ggplot2. It's not because I think they're wrong, it's because ggdensity is just this different. For me, I put all of the I sort of group objects together based on geom stat pairs. So all of the code for geom HDR and stat HDR are in HDR. If you look at ggplot2, there will actually be like a geom dash point and a like stat dash identity. Those are going to be in separate files. But for us, we just get to look at HDR, and it might look a little daunting at first because we're scrolling through and like there's this stuff that doesn't look like code, but it kind of looks like code. This is called Roxygen. This is Roxygen code, and this is how you write package documentation. Right now, we're just going to ignore it. So scroll down, and then here's something that you guys have seen before. This is how you write functions in R. So this is just going to be R code that's defining stat_HDR. We know exactly what's going on here, actually, because this is what we've been looking at all last class. It's a function that wraps a call to the layer function. Makes sense? And you can tell that this function is exported in GG density because of this, at export Roxygen tag. You don't have to know too much about that, but just know that means when you run library GG density, if you type stat_hdr, it pops up. It's not hidden. If we scroll down, here's the definition of stat HDR uppercase. This is the ggproto object. This looks identical, right? Like we just had our code that made an object that was a function. Now we have our code that's creating this object. And I'm exporting it. So organizing, exporting these environments is practically identical to exporting functions. If we keep scrolling, here's a function that's not exported. This isn't really relevant to extending ggplot2, but notice there's no at export, and that's because I don't want users messing with this. This is something that I don't want to commit to users having access to. Anyways, if I keep scrolling, here's geom_hdr, and here's geom_hdr. Very complicated. This took me a very long time. You can see I don't want to mess with grid either if I don't have to. So does that make sense? I mean, obviously, you guys haven't developed packages before, but you can see that writing a package that has a ggplot2 extension isn't going to be that much more different than just writing a normal package. You're just putting all of the code that makes those ggproto objects alongside the code that makes the normal functions that you're exporting. Does anyone have any questions? Okay. Gotta go back to the slides. We were here. So we poked around a little bit. And yeah, like I said, exporting ggproto objects alongside normal functions has pretty much no impact on your development workflow or how code is organized. So that was how ggproto impacts package development. How does the documentation of ggplot2 extensions differ from the documentation of normal R functions? I don't know if you guys use this a lot, but with ggplot2, if you just !geom_points, like you know what you're going to get, and you're going to get examples. You're going to get a section on what aesthetics ggplot2 geom_point needs or wants. You're going to get a section on what computed variables happen if they happen, and that's standard across all ggplot2 extensions. I'll show you what I mean in a second. So before I talk about that, I'm going to talk about, so there's been a lot of talk about inheritance with ggproto. This inherit is not that inherit. Inheriting parameter documentation is something that all R package developers can do. It's not facilitated by ggproto. It's actually facilitated by Roxygen and other bigger systems. But when you're developing ggplot2, it's very important because when you do !geom_points, you get that section on its parameters. And it's fairly technical and complicated. It tells you what the mapping argument should be. And that is the results of this AES function call. It tells you what the data should be. And it talks about where waivers are accepted. And you don't want to duplicate the effort of writing that documentation, because whenever you export, for example, if I were to write a package and export geom_segments, it's going to have a data argument. But that data argument is going to behave identically to the data argument from geom_point. And so you want to leverage that, and you do. And the way that you do that, or the way that I found is easiest to do that, is you just, no matter what layer function it is, you inherit from stat identity. And so that means all of the arguments that stat identity shares with your function, R is going to go find the documentation that ggplot2 devs wrote. Also, if there are other geoms that yours are related to, so with geom complete, we want to inherit from geom segment. Finally, if you are working on probably developing stats, it's likely that you're touching other packages' implementations of transformations. For example, with the stat salesperson, we used from the TSP package solve TSP. And in fact, our stat function accepted an argument that was piped directly to stat TSP, if you remember the method argument. And so we don't want to, unless TSP documentation is really bad, which maybe it is, in which case write your own, there's no rule against it. But assuming that it's good enough for you and your users, just use their documentation. This also has the benefit of if TSP is updated and they accept a new method, you don't have to stay on top of that and update your documentation. The documentation will eventually update itself. And it's a little complicated, that process, but it'll work out. It's like a quote runtime dependency. Anyways, so number one, how do you document ggplot2 extensions? You do it with inheriting parameters as much as you can. The documentation for parameters as much as you can. Second, this is what I was talking about. Whenever you're documenting your layer functions, you need to have special sections to talk about the aesthetics and computed variables. In fact, these sections have formats that are standard, and the way that you use those formats is you go to GitHub and you copy paste, you steal it from ggplot2. That's what you do. And you can make tweaks if you want them, but steal. For the record, that's what ggplot2 wants you to do. Everyone wants it to be standardized because that's what users want, I think. Yeah, and so these are in addition to the sections that are always there. This isn't too relevant to you guys, but finally, and this is always relevant, but this is especially relevant when you're extending ggplot2. You want to group the documentation of objects together logically. So remember, I was just showing you guys the sort of file structure for ggdensity, and I had one file, hdr.r, and in that file, there's a definition of all of the relevant objects. And actually, those objects share a documentation page. So if you do !stat_hdr, you get the same thing as !geom_hdr. Like these all lead to the same spot, and I only wrote it once. That's definitely what you want. And for several reasons. A, because it's easier for you. B, a user, if they do !stat_hdr, they need the accompanying documentation. You don't want to separate it if at all possible. So here's the source code for ggplot2. We're not going to go to GitHub to do this, but this is what we just saw. Like I just copy pasted it into the slide. And I'm going to highlight some of the things that we just talked about. First, this is the sort of documentation of the parameters to the geom_hdr type functions. And you can see the very first thing I do is I inherit from geom_path, stat identity, and stat density 2. That's because these help pages define arguments that are equivalent to my arguments. After that, I just have to do a couple. So like these are just, these are unique to ggdensity, and I am qualified to write these because I'm the one that's working on like the logic that involves these. I didn't really write the logic that involves these, so I don't worry about writing the documentation. Does that make sense? That kind of division of labor. Also, this way, if a user does !geom_hdr and they look at the data argument, it doesn't say something different than like ggplot2's data arguments. Next up is those special sections I was talking about. Like I said, this is copy pasted. You just kind of make a new section, and then you have a little list of all the aesthetics that you want. Yep, that's it. Then we have the last one, variables. Again, it's sort of a list of stat hdr transforms the data and appends, well, actually that's a lot, but in the final data structure that comes out of it, exists this probs column. And so I'm telling the user, hey, this is what that probs column is. I don't think that we had any variables before, so that's not really a good example that you saw in the previous implementations. But for example, stat count, if you do !stat count, the computed variable section of the documentation is going to talk about count. It's also going to talk about prop, which is the proportion, sort of a rescale version of it. Does that make sense? Okay, awesome. Last thing, so I mentioned you want to group all the documentation together, and you can actually, so up here, we are inheriting documentation across packages. You can also sort of share documentation inside of a package, and you don't have to worry about mechanically how it's happening. But here I'm saying this big chunk of documentation is called essentially has an identifier geom_hdr. And then when I define my functions, I say, hey, use the documentation for geom_hdr. And I do that for all functions. So now they all share. There's no copy pasting on my side, standardized from user perspectives. Does that make sense? In fact, there's a geom HBR lines family of functions that actually share this documentation as well. So, you know, just trying to cut down on duplication of costs. Okay, so I think, yeah, this is the last thing we're going to talk about, and that is unit testing. I think you guys have talked about this a little bit. So you understand, you know, the basic idea of unit testing, and those basic ideas work well for a lot of ggplot2 extension code. So, you know, we saw, I'm using compute_star. Good formatting. This just means, you know, compute layer, compute group, compute panel, whatever. The code that's in there is very simple. We're taking data, we're transforming it, and we're outputting data. And so you can use basic unit testing ideas to sort of give in a dummy data set where you know the answers, let the compute method do its thing, and then check after the compute method that it did it right? Works great. There's a chapter on unit tests, maybe you guys have read it, and it's in the R packages book, which gives, you know, a good overview of this strategy. Now, that strategy breaks down a little bit if you start to think about what the geom stuff is doing, because the return value of draw methods is grobs, and it does they just don't work. Like I don't think that, like, I think that the tests that unit tests tools do not work when the return values are grobs because of internal grid stuff. And the way that you get around that, in part, is with this package ggplot2 for visual something. Essentially, just like with unit tests, you give in data or arguments and you know the answer. The same thing happens here, where you provide data to a plotting function, and then it sort of saves what the plot should look like. And then when you run tests again, it makes plots again and compares them. And to do that, it's looking at like the .svg files that are outputted by the plots. Now, these aren't perfect. I say high sensitivity, low precision, meaning if you make a change in your package that breaks how plots are rendered, ggplot2 will pick up on it. It'll say, hey, this plot looks different. If you update your operating system and you make a plot, ggplot2 might say this plot looks different. And that's just because there's so much going on in the rendering of the plot. You know, changing operating systems, changing platforms, whatever, might lead to slight normal changes in the plots created by your tools. ggplot2 is going to flag them, and you just say, oh, no, that's fine. What that does mean is visual tests are not reliable. Like, you don't want to stake your package being accepted to CRAN on the results of unit tests. Unit tests, CRAN likes, I think they like them. And when you submit a package to CRAN, it'll run the unit tests that come with your package. And if any of them fail, CRAN will say, fix this before we distribute it. ggplot2, the visual unit tests are not run by CRAN. And so they're not going to be caught by CRAN if there's a mistake. But when CRAN runs your code on like this defunct, you know, Linux OS, like Solaris or something, and it breaks the visual tests, they're not going to get mad at you. So it's a trade-off. But I'm going to show you just how useful visual tests are in a second, right now. So I'm going to get out of here before jam escape. Yep. Okay, so I timed out. Give me a second. Password manager. Okay.
Y'all's password.
Yeah, I have like different passwords for everything. Talk to me about it if you care. So this right now is in a web browser. Don't worry about that. It doesn't want to go full screen. That's fine. This is how I develop code. This is a sort of, you can imagine that I'm just working on this local machine. And this is the source code for GG density. So again, we can look on the right, and here's what we saw on GitHub. Here's what we saw on the slides, right? It's the same content. if I show you guys, we talked a little bit about what the package structure looks like. We have this R directory that looks like it looked like on GitHub. There's also a tests directory. This is where the unit tests for GG density live. So I'm like testing some kind of different topics all grouped together. Here's where the visual tests live. Lots of tabs. You can see I'm using from the vdipper package expect doppelganger, which essentially says, hey, there's a plot saved with this name. This object, which is a plot object, should look the same as this file, right? And right now, if I go to the build, this is from this, don't worry about this. If I go to the build pane and I run my unit tests, hopefully they all pass. So you can see they're a little slow. That's okay. So each, by the way, the numbers that are ticking up are tests that are passed. So all of these tests are passing without failures, warnings, or S's, skips. Okay, so all of the tests pass. Great. What happens if I go in and break something? Well, let's go to autocomplete. Geom HDR. So you can see here, this is the definition of Geom HDR. We're using Geom Proto, and we're saying inherit from Geom Polygon. This is how those like density regions are drawn, because they're polygons internally. That's how they're represented. What happens if I change it to point? Oh, Zoom does not like Vim key bindings.
No.
Okay, so let's save it. And let's say like I made some other changes, and then before I tell all of my loyal GG density followers, go download the newest version, I want to make sure it works. And I press test. I actually press check, but we're not going to do that. So now it's running my unit tests, and they're all passing. Looks good for now. Okay, 2 failures. Yeah.
So if it's doing a visual, like it's comparing to a previously run plot,
Mm-hmm.
does this only work out after you've made like a successful like picture?
Yes. Yeah, that's right. And actually so that's a case for doing unit test early. So like the idea is when you make your package originally, hopefully everything's working. Hopefully you've just checked it and you know it works. You make your unit tests. As you keep going, if you break something, then it'll flag. But yeah, if you have a problem, like a bug that's been in since the inception, the unit test will not catch it. And that's a good point. Yeah. Okay, so what's happened? We've had a lot of failures. Some of these failures are going to be a little boring, like because changing this is going to break a couple things, right? What I really want to show you is how it breaks the visual test. First up, so we see visual tests. Oh, interesting. So we had a couple of visual tests fail. Let's see what they look like. What does that mean? It says, let's look at the first one. Failure, basic 2D HDRs render consistently. Snapshot of test case to visual blah, blah, blah has changed. So it's saying that the image changed, and it gives me some code to run to see what the change looks like. And this is gonna blow your mind. This is so cool. If I knew how to paste. I don't know how to paste. No.
Try edit paste
Edit. What's the edit
in
button?
the top tab.
Oh, of course.
Not that far.
Paste.
No, in your browser, like next to the.
In the RC.
Edit. Paste.
Nailed it.
Incredible. Okay, I think I know what to do. I'm just gonna drag it.
Oh. We're just gonna send our.
This isn't so bad. Visual tests. So it's going to actually call up a Shiny app. And these are the 4 tests that fail. Okay. And this is right now useless. But let's go to the slider. So this is what the test is supposed to look like. Ooh. This is what it looks like now. The slider is here because, like in this case, it's really hard to tell what changed. right? And so like, I'm going back and forth and I don't really see anything. And, oh, I see, it's this, it's the legend. The legend went from boxes to circles. Very useful. Yeah, you see though, like, this is cool. And like I said, sometimes the visual tests go off incorrectly. And to the naked eye, there's no difference. And it's because it doesn't matter. And you're gonna see that, like, you might go to toggle maybe, and it'll like automatically flip between them. And so you can kind of like inspect and see, well, what is different? So this is how this one failed. This one, oops, let's go to slider because it's so fun. This one failed like this. This one, I mean, you know, they're all the same. And so what's happened here is kind of cool if you think about it. Like right, you really want GG density is supposed to work with G on polygon, but if you use points instead, it plots the points. I get, you know, and they have the right alpha values. It's just, it's not the right graphical object that's being drawn. And so that's what visual tests look like. You guys have seen non-visual tests before. Like, I don't think I could. Oh, and then up here, by the way, there's a button and this says either, hey, this is a problem. I'm going to accept. Well, let me think. What does it say? I think that accept says, actually, the new version is what I want. And so we're going to replace the previous snapshot with this new snapshot. Skip says, oh, this is wrong. Let me fix it and try it again. I'm just going to delete everything, which I think should be as simple as reverting these. It's probably going to make me remove these files. Yeah, that's fine. Like I said, the sort of other unit tests that are not visual are very simple. I guess I'll just show you quickly what that might look like. Actually, GG density is pretty factored out, but you can tell. So here I'm just saying like, hey, the output here should be a list, and like the names of this should be this, and like this should be an ordered factor, just like basic tests on the structure of the output of what's being used in the compute groups. And that's just like what you would have in any other R package. The only difference really is those visual tests, which come from that vdiffer package. And I think that's the whole slide deck. Let's see. That's it. Yeah. So thank you guys. Yeah. Thank you. Sure.
So think about maintaining for the package.
Mhm.
So usually we download a package from the R, sometimes it's supported by the new version or supported by the old version, something. So how matter is that with the maintaining the package?
Mhm. Yes. Yeah, so you're speaking specifically about how do tests play in, or just generally what does maintaining look like? Yeah, so generally, we're extending ggplot2. And so any change in ggplot2 that hits users is probably going to hit us. A really good example of that is very recently ggplot2 formally adopted a new aesthetic called the line width aesthetic. Historically, the sizes of lines that are drawn have been governed by the size aesthetic, which is unfortunately the same aesthetic that governs point sizes. It matters. So ggplot2 extension developers had some work to do because they had to support the new line width aesthetic. Now, ggplot2 is very stable, and it's made by the people at Tidyverse, RStudio, Posit, whatever. And they really care about making high quality software. And so with that line width thing, I was kind of slow to do it, even though my package benefits from it. But that was fine because the developers of ggplot2 actually built this really cool system that let ggplot2 extension developers be slow about it. And like it issued warnings and stuff, but it didn't outright break your package if you use the new version. And so, generally when you're extending something, you are incurring a little bit of risk because like, what if you're building your package on something else, if that crumbles, like you're out of luck, until they make ggplot3. I'm not too worried. But does that answer your question?
Yes.
Okay, awesome. I think you had a question, Dustin.
Hey, James, thanks, man. It's really good.
Thank you.
Two questions really related. And one, I think you just shed some light on the answer, but I know there's a bunch of extensions, so other people have made extensions. Do they ever get pulled into like base ggplot? Like, hey, we like this so much, we want to like incorporate part of it into install that package as ggplot.
Yeah, that's a really good question. I think the answer is effectively no. So ggplot2, I read this somewhere. don't remember where, I wish I could tell you where. I read it like an opinion of a ggplot developer, which was, hey, we made basic building blocks of plots. And we don't want to get into the nitty-gritty of like, this statistical estimator is better, or this one is better. And so they're like opening up for extensions to come in and practitioners bring their knowledge and like, totally kill the problem of plotting average shifted histograms. And like, that's a great package, but ggplot2 is not interested in endorsing a particular one. Now, ggplot2 has had additions. So like the line width aesthetic is an example. Also, there was actually originally geom contour, like the ggplot version of geom HDR was a late addition that came from additional functionality. But I believe the developer that made that was a core sort of ggplot developer. It wasn't an outsider that was merged in. Did you agree with that about?
Which part? Sorry.
The person that made the geom contour 2D stuff was a ggplot dev. It wasn't like an outsider.
Yes.
Okay,
yeah.
that's what I thought. Yeah.
So if you work for POSIT, can they like incorporate your code?
Yeah, so the way that I know because I tried to work there. They'll put you on projects. And so you might be working on maintaining ggplot2, you might be working on somewhere else. I don't know how much they bring in personal projects. I know that they have personal projects. Some of those are more sort of aligned with Tigris. Some of them are about elevator data or circus wheel data. Ferris wheel data. But yeah, that's definitely a way. If you want to work on the code base of ggplot2, you can either try to work with POSIT, or they'll probably not tap you, say, hey, bring your package into mine. But if you go, we're out of time. If you go to the ggplot2 GitHub page, well, I should show you what that looks like anyways. I know we're running low on time. I promise they have stuff you can work on. Actually, they have 240 things you can work on. You can look at, so let's see, this is probably not, let's look at a bug. So here, maybe there's an issue with the new line width aesthetic where it's not being used in legends correctly. And so if you can figure out a solution, you could contribute here. And you'd have to test it and go back and forth with them, but it's open source. So it's open to contributions from the community. By the way, looking at issues, especially looking at closed issues. So like look for a bug, like here's a bug, how did they fix it? And so if you were working on a package, an extension that ran into a problem like this, finding an issue that a ggplot2 dev worked on, and you can see like maybe this is where they fixed it, like kind of go down the rabbit hole, figure out how they fixed it. And that's a really good starting place. Any other questions? Okay, did your question get answered about the after status? Yeah. Okay, awesome. Well, that's all I have. So thank you guys.
Thanks, James, again. Okay, I'll plug in my computer and we'll go for the main.
Yeah.
We are done for today. I'll see y'all next week. And if you have any questions, feel free to reach out to James.